Hello. So this is the video for assignment 6 that introduces us to the unit circle. You've heard about it, you're excited about it, can't wait to hear about it. Oh, yeah, sorry, I forgot about something, just wait. Okay, I'm back. First off, this picture here. We have two triangles. If you remember your geometry, we have angle, 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 similarity. Remember that all the sum of the angles of a triangle that lie in a plane have to add up to 180 degrees. They share an angle here, and they each have a 90-degree angle, so this angle is congruent to this angle, and they have the same shape. So you may also remember from geometry that if two polygons are similar, their corresponding side lengths are proportional. So side length AB is to BC as side length AE is to AD. Or you can say things like side AE over AB is the same as AD over AC. Right? I'm saying those particular things because if I was to put a theta here, I could say something like maybe the sine of theta is equal to BE over AB. But since these are similar triangles, I can also say that the sine of theta right there is equal to CD over AC. Right? And that's kind of a nice characteristic of similar triangles. And so the point of this is that I could make this any length I want. I could make, if I was finding the sine or cosine or tangent of a certain angle, I could use, as long as this angle was the right size, I could use any length of a hypotenuse and I would get the right trig ratio. And that's helpful because some bright fella at one point came up with the idea of a unit circle. I said, wow, I think you'll really kind of enjoy this. This is very interesting and very smart. Whoever did this is pretty bright person.
You're a pretty bright person.
We're on a unit circle.
You got that, Mattel?
So our hypotenuse here is 1. Interesting enough. And our point here, we're interested in the coordinates of that ordered pair. And remember that we walk out a certain distance, x, and then we walk up a certain distance, y, and we end up at ordered pair xy. Simple, huh? But now let's notice something. Let's notice that if we're to look at this angle and maybe ask ourselves, what is the sine of that angle theta, we have, y over 1, or just y. And then similarly, the cosine of theta is equal to adjacent over hypotenuse, x over 1, or x. Likewise, we would say that the tan of theta is opposite over adjacent, y of x. Right? From those, you could certainly get the definitions for the reciprocal functions. So in the first quadrant, if you're in the first quadrant, this is all the right triangle trigonometry that you've been doing since geometry. Right? Everything's the same here. The difference now is we're going to allow this theta to go anywhere. And we're just going to make a definition. We're going to say that on the unit circle, if you want the sine of a certain angle, go out onto the unit circle, start right here at the x-axis, measure out that angle, and find the y-coordinate there. That will be the sine. Okay? Over here, it's just, though I just drew this on the board to see what happens. This is an angle that is rotated more than 180 degrees. Maybe this is about 210 degrees or something like that. So with this new definition, we are allowed to say, what's the cosine of 210 degrees? What's the sine of 210 degrees? That didn't make sense with right triangle trigonometry. Okay, so this is just a definition. Somebody just made it up. They said, this is what we're going to do. If we're on a unit circle, we're going to define the sine function of an angle. It's just follow this point around. Turn to a degree, find the x, find the y. I'm going to stop this right now and give it over to my able-bodied assistant. That's you, handsome fella. Yep, it's your turn.
I'm doing stuff.
Yep.
I'm busy.
And he will show you how to do this on GeoGebra. And then we'll give you a short little assignment where you can kind of figure this stuff out, play with it, and get the idea. Peace out. I love you.
Isn't that something? I'm doing things. I'm busy. But he calls them anyways. I'm just sitting here waiting. Let's see. X squared plus y squared equals to 1. Huh. Check that out. Remember the equation of a circle centered at the origin with a radius of r is x squared plus y squared equal to r squared. So there's our unit circle. I am going to put a point at 1, 0 and 0, 0. So you pay attention. You're going to have to do this as well. I'm going to make an angle. I'm going to call my angle theta, and I'm just going to type it in, and so it will give me a slider. I am going to change the settings on the slider so that it is allowed to roam from minus 360 degrees. Ooh, it doesn't like when I do that for some reason. It doesn't like my tabbing. Minus 360 to positive 360. Our theta now can go all the way between there. If you want any particular theta, you can just type it in here. Okay, I'm going to make an angle with a given size. I select the leg, then the vertex. It's going to measure counterclockwise. I already have theta in here, but put theta in degrees to write that in there if it's not in there. And now my point is on the circle. Right? It has rotated precisely the same distance, A to 0, or A to O from O to A prime. So it's on the circle. It's the same distance. I'm going to put a segment there just so we can see it a little bit clearer. My point A prime, I do not want to see its name here. I want this value as it goes around. So I'm going to change the settings to show me that. Didn't work. There it is. So we are at 65 degrees. Remember what Happy Man over there told you. He told you that the x coordinate is the cosine of the angle and the y is the sine. So the cosine of 65 degrees, 42. The sine of 65 degrees, 0.91. We can rotate this around. Maybe somebody says, hey, what's the sine of 342 degrees? There it is right there. The sine of 342 is minus 0.31. Right? You could verify that by saying sine of 342 minus 0.31. There it is. Right? Okay. I am going to ask you to make this manipulative. Put in some different angle values, fill out a Google form. It's matching. I know you like matching. So all you have to do is build this little manipulative. It is asking you to please email me a picture of your little manipulative, because I know that it's tempting to just put them into the calculator. Believe me that doing this process will give you a little bit of an intuition of what's going on that you won't forget when it's that frightening ACT time or whatever it is. All right. Good work. I love you. Do it to it. Keep your stick on the ice.